run through two sections today. They're both really short. The first one you've talked about since probably 5th or 6th grade. Okay, at least the majority of that first section. So measures of central tendency. Think of this as measures of center. Okay, central tendency, measures of center. So let's say you have a data set and you were trying to measure the center. What would you use? What type of measurement would you use to measure the center of data? No ideas? Median. Median means middle. Okay, what else? Are we awake? Are we alive? What else? Okay, mean means what? Average, okay? Your 3 M's, mean, median, mode. Those are your 3 measures of center. What's another way to say mode? Most frequent. Okay, so mean, you've seen this before, maybe not a ton. When it's denoted by an X with a bar over it, and it's red, X bar, that stands for mean or average. How do you find the mean or the average of something? Add them all up and divide by however many you have, right? Add them all up, divide by however many you have. Median, the middle when your data is in order. The middle when your data is in order. And remember that that's the key. It needs to be in order to be able to find the median. What if you have an even number of data points and you were trying to find the middle, so you got to the middle and you had 2 points in the middle? Then what do? Right, yep, add them up and divide by 2. Good. Mode, most frequent. Okay, again, most. There may be one mode if there's only one number that happens more frequently than the others. There may be no mode if all of your data points happen the same number of times. Or there might be more than one mode. Maybe you get the number 3 and 7 more than any of the other ones. So you could have more than one as well. All right, so how to use your calculator, because you're going to need to know how to do this on your calculator. We're not going to do this by hand. You guys have done mean, median, and mode, like I said, since middle school for sure, if not before. So we're going to use your calculator for it. You're going to enter your data, stat edit, just like we were entering in our lists for binomial PDFs. Okay, and you're going to use one variable statistics. One variable statistics. Okay, so let's do this. Grab your calculator. And I have some data here about heights of waterfalls. So go to Stat Edit and enter these in. And it's best if you can enter them in under List 1. If for some reason your List 1 isn't there, go to Stat, and instead of going to Edit, go to Setup Editor and press Enter twice, and it'll come back for you. Okay, so we all have these in our statistics, in our Stat Edit. I have all my data points here. A good way to know to make sure you didn't miss any, see this on the bottom here, List 1, L1, number 8. You want to make sure that you have 8 data points in your list and not 9 or 7. Okay, after that I'm going to again go Stat. But now I'm going to go over to Calculate. And there's your one variable statistics right here on the top. One variable statistics, I'm going to press Enter. Now, if you entered it in List 1, that's all you need to do. You press Enter again, it's going to give you all your information. If you decided I don't want to put it in List 1, I want to put it in List 3 because I have stuff in the other lists that I wanted to keep, Then I need to tell my calculator that, and I'd put in list 3, or whatever list I was using. Okay, so I pressed enter. Everybody have this? This gives you all kinds of information, all right? More than we're going to need. But what's the first thing that you see on there? What's that X bar stand for again? The mean, the average. So this one right here, that's your mean, okay? So you don't ever have to add anything up again and divide by however many there are. That's going to be your mean. The second thing you see, this E-shaped letter, this is a Greek letter standing for sigma. Sigma stands for the sum. So if you added up all of those data points, you would get this number, 10,752. Okay. I'm going to skip down then. This n equals 8 again stands for how many data points you have. If you keep arrowing down, we end up with the median, M-E-D, median. You're also given your minimum and your maximum, which is kind of nice. What don't you see up there? The mode isn't up there. So that's something that you have to figure out on your own. Your calculator doesn't tell it to you. Okay, so what would our mode in this problem be? 1,000. That's the only number that happens more than once. Questions? Okay. All right, measures of dispersion. This is the second part of the lesson. It tells us how spread out our data is. And there are two types of measures of dispersion that we're going to talk about today. One is range, which you guys have done a lot of. Maximum minus minimum. Greatest minus least. Okay, the other one is standard deviation, and this is new. You probably haven't done much standard deviation, I don't think, in any of your classes before. This is going to be the lowercase sigma. Okay, it looks kind of like a P almost, that's sideways. It's a little circle with a little line going off to the right. Okay, and I'm not going to make you memorize that formula at all. If you are writing down notes on your own, this is in your book, so you can copy it down. But we are going to do this once by hand, just once, so you know what your calculator is doing when it tells you about sigma. Okay, so the steps to figuring out standard deviation, again, talking about the spread of data. First thing you have to do is find the mean, because you notice in the formula, you have all these X bars going across. Step 2, you're going to find the deviation. Deviation is another way to say the difference. What does difference mean? Subtract, right? Subtract. Find the difference of each value from the mean. So here's my first data point. I'm going to subtract the mean from that. I'm going to take my second data point, and I'm going to subtract my mean from that. Then I'm going to square each of those. So I found each of those deviations, the difference between those two values, and I'm going to square it. And then I'm going to add the squares. I'm going to find the sum of each of those. And again, we'll go through and we'll do this just once, and from then on we'll use our calculator. If we take that big long sum and we divide by n, n being our number of data points, oops, that's not what I want. Here's another vocab word for you. This is one you're going to want to know. That's the variance. A lot of times the variance will be represented by sigma squared. And then to find sigma, the standard deviation, you just take the square root of that. Okay, so again, we're going to do this right now, and this will come up on my next slide too for those of you that are writing this down. All right, so we have standard deviation. We have that formula up there. And I have waiting times for going to this office up on top here. So first thing I want you guys to do is to find the mean, and you can either do it on your own by adding them all up and dividing by how many, or you can put it into your stat edit spot on your calculator. Okay, we're not going to take a whole lot of time on this. We found that the mean, make sure you're using your notation. That's going to help you so you don't forget it. X bar is equal to 22. Does that sound right? Okay, that's the first thing we need. And we're going to find the deviation, the difference of each of these values that we have up here from the mean. So in my little table here, I have this set up to help us. Let's enter all of our data points. So we had 14 and then 17 and so on. And then your next step is to find the deviation, the difference of those data points from the mean. So for the first one, I'm going to take 14 minus 22, which is going to give me -8. And then 17 minus 22, which is going to give me -5, and so on. You guys find all of those deviations. And then check my math up here to make sure that I didn't make a mistake. Any other ones that look wrong? Okay, your next step is to square each of those. Now, what happens when you square a negative number or a positive number? You always get a positive, right? -8 squared is still positive 64. So write down all of your squares. And then once you're done with that, you can add each of those up. We're finding the sum of the squares. Did you guys get 290? Does that sound right? Yes. Added all those up. We get 290. So we have that sum. Okay, so now we're going to take that sum and we're going to divide by n. So 290 divided by how many data points we have. Let's count them all up quick. And I believe we have 9. Yes? Okay, so I'm going to use my notation again. This is sigma squared, which is equal to the variance. And if I want to find the standard deviation of that, I'm going to take the square root. Which should be about 5.7. Okay, so what does this tell us? Well, again, it tells us about the spread, and typically what we would do is compare this to maybe another office's waiting time. And if they had a larger standard deviation, that would mean that their waiting times were more spread out than this office. Okay, if they had a smaller standard deviation, that means that their waiting times would be less spread out than this office. And as we get further into Chapter 11, we'll use standard deviation in other ways as well to talk about differences in data. Okay, so this is just another way to say that groups with data close to the mean, okay, close together, are going to have a smaller standard deviation, and then groups with data farther from the mean are going to have a larger standard deviation. If you look at your calculator from before, and we notice Now you have used your calculator since then, so it's going to look a little bit different here. But I have a standard deviation for that waterfall problem right here. So like I said, you don't ever need to do standard deviation again on your own by hand. We're going to use our calculator to figure that out. It's just too long of a process. We can make too many mistakes along the way. So you're going to use that one variable statistics again. Same place you find your mean, same place you find your median to find that standard deviation. So notice that this is sigma, and then they just use an x after it. An outlier. An outlier is a value that's a lot less or a lot more than all of the other data points. Okay? And this is another type of question that you're going to see on the MCA test, or possibly the ACT, but definitely more MCA. Outliers are going to affect the mean the most versus median and mode. Okay, so this would be a good quiz or test question. What does an outlier affect? And it would affect the mean. It's also going to cause the range and then the standard deviations to increase because it's going to cause your spread to increase. Okay, so we're going to examine an outlier in this problem. You have winning scores for an air hockey tournament, and go through and find the answers for each of those steps. And again, you can use your calculator to do that. Okay, so let's run through these quick. You may not have had a chance to completely finish, but I entered all my data. I found that the mean was 14. Remember that that's this X bar up here on top. The median is 14.5. My mode, the most frequent number, was 15. The range, so now it doesn't give me my range either, but I do have my minimum and my maximum on it. So maximum minus minimum, 17 minus 11 is 6. And then standard deviation, I'm going to arrow back up and find sigma here, 1.67 or approximately 1.7 is my standard deviation. Now, in part B, they're telling us that we have an outlier of 3. So I'm going to go down and I'm going to enter in a 3 here. And it's an outlier again because it doesn't match the rest. And then I'm going to calculate it all again. One variable statistics. And there we go. So now our mean is 13. Our median is 14. Has our mode changed? No, that's still 15. Our range, now we're going from 3 to 17. So 17 minus 3 is 14. Okay, so our range has increased a lot. And our standard deviation is now 3.54, which is a big jump. It doesn't maybe seem like it from 1.7, but for it to double, a standard deviation to double, that's a huge jump. So which measures of central tendency does it affect the most? Remember, central tendency or center, mean, median, mode. Which one did it affect the most? A mean. The mean changed by one full number, full whole number. Okay, the other ones, the mode didn't change at all. The median changed by 0.5. Which does it have an effect on the range or the standard deviation? Yeah, the range increased by a lot. The standard deviation also increased by a lot. The standard deviation doubled. Questions? Okay, that's everything for 11.1. 11.2 is all summed up on this one page right here. Okay, adding a constant. I want you guys to open up your book to page 751. And look at example 1 with me. We're exploring in this problem what happens if we add a number to each of our data points. What happens to our measures of central tendency and our measures of dispersion? Okay, so in this example, we have astronauts' weights in pounds. So these are all of our weights here. Okay, and then they add on how much the suit weighs that they need to wear in space. So the suit is weighing 250 pounds. Can you imagine walking around with a suit that weighs 250 pounds? Granted, in space, you're weightless. So, but so they've added this 250 to each of these data points. And the question is, what happens? Okay. Well, what happens is the mean is going to go up by 250. The median is also going to go up by 250. The mode is going to go up by 250, but the range and the standard deviation don't change. Okay. Think of why that is. If I add 250 to the lower number, and I add 250 to the higher number, has the distance between those two numbers changed? No. They both went up by the same amount. And the same thing with the spread, the standard deviation. We've just shifted all of those numbers up by 250. The spread of the numbers hasn't changed either. So it's just those three that are going to change. Okay, so that's the notes that you have here. The mean, median, and mode can be found by adding the same constant, just like in this astronaut problem. The range and the standard deviation don't change. So basically, this section is a shortcut for you. Let's say you found those measures for your original data points. You don't have to add 250 to all of your data points and then find it again. You just add 250 to the mean, median, and mode, and then standard deviation and range stay the same. Okay, let's look at example 2. Okay, so we have the distances of these triple jump winners in meters originally. Okay, that's what all of these meters, all of these measurements up here are all in meters as well. Okay, find the mean, median, and mode and standard deviation in meters, which they've done here, and also in feet. So what they needed to do then was multiply all of those numbers by 3.28 because there are 3.28 feet in 1 meter. Okay, so imagine that you multiplied all of those numbers, all of those triple jump distances by 3.28. What would happen to the mean, median, and mode, standard deviation, and range? Well, it's going to again multiply your original mean, median, and mode all by that 3.28. But it's also going to multiply the range and the standard deviation. Okay, you have a smaller number multiplying by 3.28 versus a larger number multiplying by 3.28. They don't stay the same distance apart. Okay, the distance between them is going to spread out. So in this case, you're multiplying all 5 of those measurements by that constant. And that is also summed up here. If you're multiplying, okay, something different happens. You're going to multiply all 5 measurements by that constant. And again, just a shortcut, right? You could find all 5 of those measurements for the original data, and you don't have to multiply each of your data points by 3.28, just multiply your answers by 3.28, which will save you some time.